I hope you did fine on those trig intervals involving cosine and sine. Now, just a quick review because it's going to kind of be the same thing today with secant and tangent. You know, when you've got sine and cosine, what you're really doing is you're saving either one sine or one cosine, and the thing you're saving is the derivative of something. So if you save a sine, everything else has to turn into cosines, okay? And if you save a cosine, everything else turns into sines. Okay, what we're going to do today is really similar to that, but we're dealing with secants and tangents. Now think about it. What's the derivative of tangent? Okay, it's secant squared. Okay, so one option is going to be to save a secant squared. And then remember, what did we just say? What is secant squared the derivative of? Well, it's the derivative of tangent. So if you save a secant squared, everything else turns into tangents. And then just like before, you're going to go back to those Pythagorean identities, and there's one that says 1 plus tangent squared is secant squared. So you're going to use that identity to make a substitution. So when you save a secant squared, everything else turns into tangents using that Pythagorean identity. And it's like before, you multiply these out, and it's going to be a bunch of power rules. Okay? Now, what's the derivative of secant? Okay, do you remember that the derivative of secant is secant times tangent? Okay, so your other option, you can either save a secant squared, or you can save 1 secant times 1 tangent. Okay, so if you save a secant tangent, now remember, what is secant tangent the derivative of? Well, it's the derivative of secant. So if you save a secant tangent, then everything else turns into secants, and you do the same thing. You multiply this out, and then you have a bunch of power rules. Okay, all right, so let me find my PowerPoint, okay, and we'll kind of talk you through a few things. Okay, but basically, I've just told you everything we're really going to do. Okay, we're just going to go through some examples. All right, so trig intervals that have secants and tangents. Now, remember what I said. Anytime you see anything, especially trig, the first thing you do is it one I have memorized. So, you know, you have several of them that we went over at the beginning of the semester that are memorized. So if it's one of those, you just write the answer down and go on. But do remember that anytime it's trig, you do have to have the derivative of the angle. So don't forget that part, okay? But if it's something involving secants and tangents and it's not one you have memorized, all right, or one of those that deal with natural log, don't forget about those, okay, in your book. They should be in your notes. Then here's kind of what you might do. Okay, so it says trig intervals with secant tangent guidelines. So like I just told you, one possibility is to say the secant squared factor and then convert all the remaining things to tangents, because the derivative of tangent is secant squared. Okay, option number 2, save a secant tangent factor. In other words, 1 secant times 1 tangent. Now, what is secant tangent the derivative of? Well, it's the derivative of secant. So if you save a secant tangent, everything turns into secants. Now, some other possibilities are on page 535 in your books, but I'm not going to take time to go through those because you can read. Okay, so there are some other options, but these are your top 2 to try first. So like I said, it's very similar to sine and cosine, because what you're really doing is you're saving the derivative of something, and then you're making a trig substitution with those Pythagorean identities, and then you're going to expand, end up using the power rule. Now let me kind of show you one. Okay, you're integrating secant 2x to the 4th and tangent 2x cubed. Now remember, secant to the 4th 2x means secant of 2x and a parenthesis to the 4th power. Okay, now this is not one you have memorized. Okay, so you got 2 options. So I'm going to walk you through both of the options, because in this particular thing, either option would work. Now I'll show you some in a minute where only one option works. But personally, if you were to see me at my desk trying to figure out what to do, normally I set up both options and then decide which one I want to do, rather than trying to memorize in the guidelines in your book. Okay, so one possibility is to save a secant squared. Okay, so I wrote it in red so you can kind of follow it. Okay, now what ends up happening here basically is I've saved a secant squared. Now notice I have 4 of them, so if I save 2, that leaves me 2, because see, secant squared times secant squared is secant to the 4th. So if I say the secant squared, now remember, what is secant squared the derivative of? Well, secant squared is the derivative of tangent. So everything else has to go to tangents. So this secant squared has got to turn into tangent. So like I said, that Pythagorean identity, I told you that you only had to memorize 3 identities, and they were the 3 Pythagorean identities. This is one of them. 1 plus tangent squared of an angle is secant squared of that same angle. Okay, so this 1 plus tangent squared is replacing this secant squared. Now tangent cubed is already tangent, so it just comes down. So notice what I've got. I've got a secant squared, and then everything else turns into tangents. Now just like with sine and cosine, you'll see me write in a different color or underline it or something. So that's my memory trick to myself. Do not touch this. This thing you're saving is going to be the derivative of something, so you're going to need it later. Then I multiply this out. Well, 1 times tangent cubed is tangent cubed. And then 1 times this tangent squared times this tangent cubed is tangent to the 5th. And I went ahead and broke them up just to save some room. So there's my tangent cubed, okay, with my, there should be a plus between them though. All right, so we might need to go fix that in a minute. Okay, so you fix that because right now I can't find my notation thing to fix it. So I'm trusting you to fix that in your notes. So that should say secant cubed plus tangent to the 5th times that. Okay, so secant cubed times that is what I've got right here. So I'm going to integrate that plus, and then that tangent to the 5th times the secant squared is right here. But don't forget to go back and add that plus right there. Okay. So look what you've got. This, what is secant squared the derivative of? Well, this is the derivative of tangent. Now, I went ahead and wrote that third power on the outside, so you would notice it is power rule. So when you have something to a power, remember, what do you need? You need the derivative of the inside next to it. So the derivative of tangent of an angle is secant squared of that same angle, but I still need the derivative of that angle. So that's why I put a 2 here. But now if you multiply by 2, remember, you've got to also multiply by 1/2. All right, now let plus, let's go do this one. I've got something to a power, so I need the derivative of the inside. So the derivative of tangent of an angle is secant squared of that same angle, which I have, but I'm missing the derivative of that angle. So I've got to go get the derivative of that angle, that 2. So I multiplied by 1/2. So I just got power rules. I've got something to a power, the derivative next to it of the inside. So that's secant squared 2x times 2, just the derivative of that inside tangent 2x. So remember, I stay the same. My power goes up by 1, so that 3 goes up to a 4, and I divide by that same power. Same thing over here. I've got something to a power. The derivative of the inside's right there. So my power goes up to a 6, and I divide by 6, and all I did was just multiply out my denominators. And then remember, it's indefinite. Don't forget that plus C. Okay? So now let's go look at your option 2. Same problem. Okay? It's the same problem. But this time I thought, well, what if instead of saving a secant squared, what if I saved a secant times a tangent? So if I saved 1 secant and I had 4, that would leave me 3. If I saved 1 tangent and I had 3, that would leave me 2. Okay? So now what is secant tangent the derivative of? Well, now it's the derivative of secant, so now everything turns into secants. Well, that's already secant, so it just came down. Now remember, 1 plus tangent squared is secant squared. So if you solve it for tangent squared would be secant squared minus 1. Okay, so that's why that turned into secant squared minus 1. All right, then I do the same thing. I multiply, a cube times a squared is a 5th, and then it says minus, and then a cube times a 1's a cube. All right, then I broke them up separately. Remember, this secant 2x, tangent 2x goes with both of those. So I've got the secant 2x to the 5th times that, minus, and then I've got that secant 2x to the 3rd times that. Now remember, this secant 2x, tangent 2x is going to be the derivative of the inside, all right? But I'm missing still the derivative of my angle 2x. So the derivative of 2x is 2, so if you multiply by 2, you got to multiply by 1/2 out here. Similarly, if you multiply by 2, you got to multiply by 1/2 over here. So just notice, this secant 2x, tangent 2x times 2 is just the derivative of the inside, okay? So you've got something to a power, then you got the derivative of the inside next to it, so it's just power rule. So your power goes up to 6, and I divide by 6. Over here, your power goes up to 4, I divide by 4. Then I just multiplied the bottom out, the denominators, and put that plus C. But now notice, this answer is correct, and it's in terms of secants. If you go back, this answer is correct, and it's in terms of tangents. So let me warn you, when you're doing your homework, if you have the option really of doing either one, the back of the book's only going to have one answer. Okay, not all the right answers, one right answer. So sometimes you may have a right answer in a different form. So you may need to just not panic. You can email it to me or go back and do the other substitution to see. Now, let me show you one that you have two options, but both won't work. I've got a secant and a tangent both to the fourth power. So one option is to say the secant squared, and then one option is to say the secant tangent. Now look what happens if I say the secant squared. What is secant squared the derivative of? Well, secant squared is the derivative of tangent, so everything else has got to turn into tangents. Well, this one's already a tangent, and sure enough, I know that I can solve, 1 plus tangent squared, secant squared. So I can work number option 1, okay? But look what happened on option 2. On option 2, if I say the secant tangent, I have 4 secants, so that's going to leave me 3, and I have 4 tangents, so that's going to leave me 3. Well, now the reason I can't work this one, my Pythagorean identities are all substitutions for even powers. They're all substitutions for squared. And I don't have a squared or a multiple of a squared. I just have cubes. So I can't change everything else to secants, because I don't know a substitution for tangent cubed that deals with secants. I know one for tangent squared that deals with secants. So option 2 would not work. I'd have to go back and work it with option 1. Okay? All right. So does that make sense to everybody? All right. So let's go work it. So we have that option. All right. So I'm not going to work it out. You can work it out. Okay. Not a problem. Now let me show you some that look a little odd. Okay. And then I'm going to show you the 2 options, and I'm going to work the one that works on this one. Now remember, a root is a power of a 1/2. So I don't have anything about roots. Okay. So one option is to change it to a power. Remember, the square root's a power of 1/2, but if you move it up, it becomes a negative 1/2. Okay. And then again, you've got cubed. So option 1 is to say the secant squared. Well, you say, well, I don't have 2 of them. I only have a negative 1/2. Well, that's right, but think about powers, okay? If you say the secant squared, how many would that leave? Well, obviously, it's like being in debt and spending more money, okay? You were already down a negative 1/2, so if you go down 2 more, negative 4/2, you're going to be down a negative 5/2. Now, if you were to see me doing it on my paper, what I do is say, what do I add to a negative 1/2 to get me a positive 2? And I come up with this negative 5/2. Okay? Now, what is secant squared the derivative of? Well, this is derivative of tangent. But see, I don't know a substitution for secant 3x to a negative 5/2 power. So option 1's not going to work. So option 2, I could say 1 secant and 1 tangent. Now notice you had 3 tangents. So if you save 1, that leaves you 2. And then the same thing. You're already down a 1/2. So if you spend 1 more, now you're down a negative 3/2. So if you multiply a negative 3/2 times a 1, remember you add. So a negative 3/2 plus 1 is a negative 1/2. So I know that I did my fractions correctly. Now, what is secant tangent the derivative of? Well, secant tangent is the derivative of secant. So everything else has to go to secants. Okay? So remember your substitution. 1 plus tangent squared is secant squared. So tangent squared is secant squared minus 1. All I did there was kind of write down about the powers that I got that from, that negative 3/2 from a minute ago, in case you want to kind of stop the video and double check my arithmetic. Okay, so secant tangent is saved. Everything else turns into secants. Then I just multiply them out. Now remember, what do you do with powers when you're multiplying? You add them. So 4/2, a 2 is 4/2. So 4/2 plus a negative 3/2 is a positive 1/2. All right. So basically that's where I got this positive 1/2 here. And then of course 1 times this negative 3/2 is going to stay a negative 3/2. So all I did here basically was move that power out, basically I I did 2 times that and got that, and then multiplied it out. Then remember that, oops, sorry, I lost it. Let me go back. All right, so remember that this is going to be the derivative of something, and I've split it up. So this secant tangent goes with that 1/2, and this secant tangent goes with that -3/2. And then remember, this is the derivative of something. Secant tangent is the derivative of secant, but I'm still missing the derivative of my angle. So I'm going to need to multiply by 3. I just underlined it, and then I've got to multiply by that 1/3. So this secant 3x tangent 3x times 3 is just the derivative of this inside. Same thing happened over here. I had to get the derivative of the inside. So now it's got power rule. So when you add a 1 to a 1/2, you get a 3/2. Now remember, you've got to divide by 3/2. But what's the same thing as dividing by 3/2? Multiplying by 2/3. Okay, same thing over here. I'm supposed to be dividing by this -1/2, but dividing by a -1/2 is the same thing as multiplying by a -2. And I ran out of room, so you can multiply those fractions out and multiply those fractions out and get your final answers. Okay? Now look at this one. This one's only tangents. So what do? I can't say the secant squared. Okay, I don't have any secants, and I can't say the secant tangent. So what do you do when you've only got tangents? Well, remember those guidelines I told you to kind of look in your book that I wasn't going to spend a lot of time on? This is one of them. If you've only got tangents, change one of your tangent squares to secant squared minus 1. That's that Pythagorean identity. So I looked at tangent to the 4th as a secant tangent squared times a tangent squared, and then did substituted one of those. Then when you multiply it out, well, see, secant squared is the derivative of tangent, so this one I can already work. Okay, so I saved a secant squared and turned everything else into tangents, but everything else already was tangents. So I've already got something here. I've got something to a power, and I've got the derivative of the inside next to it. Because remember, what's the derivative of my angle x? It's 1. I've already got that. So this one's already workable. All right, so remember, my power goes up to 3, and I divide by that same power. Well, now go back here. I don't know what to do with tangent squared. Okay, I don't have anything to save, so I've got to do the same thing I did up here again. I changed that tangent squared into secant squared minus 1, and then separate them. Secant squared times dx here, 1 times dx there. Now, don't miss something that's simple. This is one you're supposed to have memorized. When you integrate secant squared, you just get tangent back. Because remember, again, the derivative of the angle is just a 1, so I've already got that. Okay? Now, minus this negative is going to make it a plus. And then, of course, when you integrate dx, you just get x back. And then you've got that plus c. Okay? So it's not hard. There's some other ones I'm going to put, out of your book. Now, remember, I'm not saying everything on your homework is going to be just like this, but these are going to be the majority of what you're seeing on your homework. So remember, those Pythagorean identities are what you're going to be using. So make sure you start memorizing those 3. Okay? And then you got options. You can save the secant squared and turn everything else into tangents, or you can save the secant tangent and turn everything else into secants. Okay, so same thing as usual. Go try that homework. If you're having any trouble, email me. Okay, you can send me your work and I'll find your mistake and send it back. We can set up a Zoom meeting, anything like that. But don't get behind on this trig, okay, or it'll kind of snowball on you. Okay. Now, the other thing I want to remind you of, this is more, but let me switch to a mama kind of Dr. Dan kind of thing, and that is this. You're going to have your book and your notes when you're taking your 3rd test, but if you don't study and keep up, you're not going to be able to finish it in your 2 hours. All right? So I need you to go memorize those Pythagorean identities, even though you'll have them to look at. I need you to kind of memorize these guidelines, even though you'll have your notes to look at, so that I want you to be ready to take the test without book and notes. And then, oh, what a lovely surprise, I get my book and my notes. Okay, so don't get lazy. All right, so if you need some help, contact me. All right, bye-bye.